Hello students, welcome to analysis of indeterminate structure class. Last class we solved second problem, but we stopped in the stage where we stopped for applying slope deflection equation, but today we will continue the applying equilibrium condition. From this step we will continue. You can once again you can recall, that means once again you can watch the last video, and this is the continuation from last class. Okay, this is the third step in equilibrium condition, applying equilibrium condition. At end hinged support A, that means the hinged support at A, the moment AB is equal to 0 by equilibrium condition. That means we know the equation for moment AB. You can directly take that equation. We are already solved this equation last class. Can directly take that equation and give the equation number 1. Okay, next, at intermediate support B, by applying equilibrium condition, the moment BA plus moment BC is equal to 0. Here we already derived the equation for moment BA and moment BC. Here, for applying this equation, equilibrium equation, moment BA plus moment BC is equal to 0, then we can substitute the moment BA plus moment BC in the place here. That equation we can substitute here. Okay, by substituting and solving that equation, we are getting this final equation. This you can give the equation number 2. After at joint C, intermediate, moment CB plus moment CD is equal to 0. Here also we know the moment CB equation and moment CD equation. We can directly substitute the moment CB and CD equation here and solve that equation, and we are getting the equation number 3. Okay, after solving this equation number 1, 2 and 3, we are getting the theta values, theta A, theta B and theta C in terms of EI, because EI is constant. The value is not given in the problem, so you don't assume, and also you can directly keep it that constant value like EI only. Okay, here by solving equation 1, 2, 3, here see, observe, three equations are there, 3 unknowns are there. Here unknown also 3, theta A, theta B and theta C. So here in this condition you can directly use the calculator by 3 equation solving mode. You can directly use calculator and solve directly, because it will take less time okay, and after calculating final moment, after calculating this, you can substitute this theta values in the equation number 1 to 5, 1 to 4 is 1 to 4 and calculate the moment AB BA, BC, CB, CD. Okay, you are getting this answer in terms of kilonewton meter, in the unit of kilonewton meter. Okay, this is the final moment. And the next step is for calculating. Next step is the calculation of reactions. Why? What is the purpose of calculating this reaction? We want to draw the shear force diagram. So these reactions are needed for drawing shear force diagram. These moments are required for drawing bending moment diagram. Okay, here reactions are, you can calculate like this. Take summation of vertical force is equal to 0. That means VA plus VB plus VC. Okay, this support reactions you can consider VA, VB, VC is equal to 60. That means upward force is equal to downward force. 60 plus 100 plus 30 into 5. This UDL load. Okay, total 310 you are getting. Next, take moment at point B and consider left hand side. Consider left hand side. Okay, and solving this you are getting VA value, and similarly calculate for VC, VB, and finally you can draw the shear force diagram like this. Okay, last problem I explained how to draw this shear force diagram and all. The same procedure you can follow here. Okay, yes, and this is the shear force diagram, and you can draw the bending moment diagram also. Free bending moment for AB and BC. This is the free bending moment diagram. For calculating this, directly use the reaction for calculating free bending moment diagram. So the free bending moment value. Okay, and here for UDL you can use this formula. And finally you can draw the bending moment diagram like this. Okay, and this is the elastic curve. For drawing elastic curve, don't mention, not needed any values and all. You can directly show the how the beam will going to deflect. Okay, just show the deflection of the beam. Not needed any values in the elastic curve. And for drawing bending moment diagram, very first you can mark the free bending moment values, free bending moment values. Okay, first draw the free bending moment diagram. After you can what we calculated by using slope deflection method, that values you can use and join the point. Okay, like this. And the pattern you can observe in the type of overhanging we are using like this parabolic shape. This is the one of the example problem by using slope deflection method. You can write down and practice is very important in this type problem. You can compulsorily you should write down your notes in your notebook these all the steps. If you have any doubt, please ask me or please comment me. I will definitely suggest you. I will definitely help you. And take down one homework problem. This is the homework problem. You can try. If you are not getting, definitely I will help you. Okay, if you have any doubt, please ask me. Please note down this homework problem. Here you can analyze the problem, given problem. Analyze the continuous beam shown by slope deflection method. Support B sinks by 8 mm. Here given sinking value, so that means we can consider del. In the space of del, you can substitute the 8 mm, or that 8 mm you can convert to meter, because in all other parameters are in terms of meters. So you can convert to meter and substitute there and solve the equation. That is the little difference here, nothing else. And also you can take the EI value, but last problem we kept the EI is constant, but because they are not given the value, but here the value is given, then you can substitute. Okay, 15,000 kilonewton meter square, you can directly substitute and solve the equation. You are getting the correct answer. And observing the continuous beam, the support AB are simply supported and C is the fixed support, and for span DA is overhanging span, and the load condition on the span BC is uniformly varying load. UVL is given 25 kN per meter, and on the span AB the moment is given directly. You can take this moment, okay, 150 kilonewton meter, and the point load is given at the overhanging end point D, that is 20 kilonewton. You can observe and you can use the fixed end moment formulas and calculate the fixed end moments, and you can the steps are same. After you can use the slope deflection equation and solve the equation, and you are find out the theta values and substitute the theta values in the equation, and you are getting the moments AB and BC and all, and using that equation, using those moments, you can draw the bending moment diagram and shear force diagram. Okay, and also you should draw the elastic curve. Okay, thank you.